Imagine a world where machines don't just see, compute, or predict, but they can smell, not metaphorically, literally. A world where devices can detect the scent of disease before symptoms appear, sense food spoilage before it's visible, and pick up toxic chemicals before they become dangerous. Well, that world isn't science fiction anymore. It's already emerging, and the field behind it is called machine olfaction. For most of human history, smell has been one of the least understood senses. Vision and hearing have been digitized for decades. Cameras and microphones record light and sound as data. But smell? Smell is chemical, chaotic, and incredibly complex. To a machine, it has always been noise. Until now. So how do you teach a machine to smell? It starts with something called an electronic nose. The earliest prototypes appeared in the late 1980s. They used metal sensors that reacted when exposed to certain chemicals. But they had a problem. They weren't selective. They could detect that something changed, but not what changed. Like a person walking into a kitchen and saying, "I smell something," but having no idea if it's fresh bread or a gas leak. Useful? Yes. Precise? Not even close. Fast forward to today. Machine olfaction has evolved from clunky hardware into a fusion of nanotechnology, artificial intelligence, and biomimicry. Now, devices don't just detect odors. They recognize them. They interpret them. And with AI, they can even predict outcomes because of them. One of the most promising breakthroughs is using machine smell for early cancer detection. Human bodies release volatile organic compounds, VOCs, through breath and sweat. These chemical signatures change when cancer begins forming. Dogs can smell it. And yes, trained medical dogs have detected cancers humans missed. Now, AI is learning the same skill. In recent clinical studies, machine olfaction systems have detected lung, breast, and prostate cancers, with accuracy comparable to, and in some cases exceeding, traditional medical screening methods. Think about that. A future where a breath sensor in your home alerts you to the earliest signs of disease, years before symptoms appear. Now let's shift to something more familiar. Food. Around 1.3 billion tons of food are wasted globally each year. Most of it because expiration dates are estimates, not science. But imagine yogurt that knows when it's actually going bad, or packaging that changes color when bacteria begin growing. Researchers are now embedding machine olfaction sensors into food containers. These systems don't check dates, they check actual chemistry. Smart refrigerators could soon scan groceries and warn you before spoilage happens, or automatically reorder only what's necessary. Goodbye, guesswork. Hello, precision. Machine smell is also reshaping environmental safety. Pollution isn't just visible, it's chemical. And some of the most harmful toxins are odorless or too faint for humans to detect. AI-powered drone swarms are now being trained to fly through disaster zones, detect gas leaks, trace wildfire smoke patterns, and identify early signs of industrial contamination. One system can identify methane leaks with near-instant accuracy, something that previously took teams of specialists and hours of testing. The result? A safer, faster response to environmental emergencies. But perhaps the most surprising use of machine smell is in emotional computing. Human emotions subtly change our body chemistry. Stress, fear, excitement, each has a unique chemical fingerprint. Researchers are experimenting with wearable sensors that could detect emotional states in real time. Imagine mental health tools that don't wait for a crisis, but see it coming chemically and intervene early. We're not fully there yet, but the prototypes already exist. Now here's the question everyone eventually reaches. If machines can smell like living organisms, will they smell better than us? The honest answer is yes, in many ways. Humans have about 400 types of smell receptors. Dogs have nearly 1,000. A machine? It could have thousands or millions, depending on how many signals we teach it to differentiate. And unlike humans, machines don't get tired, sick, biased, or confused. Smell to a machine is data, clean, structured, and infinitely repeatable. But as with every major technological shift, there's a shadow behind the promise. Machine smell has profound privacy implications. If a device can smell health condition, emotional states, drug use, reproductive status, or genetic disorders, then smell becomes a biometric signature, a signature you can't hide. Your breath becomes a medical record. Your sweat becomes metadata, and suddenly the question shifts from, can a machine smell this? To, who owns what it smells and who gets access to it? As machine olfaction scales, ethics, regulation, and transparency will matter just as much as innovation. Still, the potential is extraordinary. Machine smell could help cure disease, prevent accidents, reduce waste, and protect ecosystems. We are entering a world where smell, the most ancient of senses, is becoming digital. A world where your devices don't just listen or see, they sense. And maybe in the near future, when you open a refrigerator, breathe into a medical sensor, walk into a city, or talk to a device, it will already know, invisibly and silently, what the world smells like and what that means. This is Neural News, where future science meets real-world impact. Subscribe, because the next sense machines learn might be ours.